In this video, I am going to show you how to write a piecewise function for graphs like this one and this one, and we'll analyze those piecewise functions, and I will show you how to evaluate piecewise functions. So technically, this is the graph of an absolute value function, but we're pretty much going to ignore that fact and just treat this as any other piecewise function. So I'm going to color code this to make it easier for you to follow what I'm doing. So let's look at this side of the function as blue, and we'll look at this side as red. So if I want to make a piecewise function, so we'll have f of x equals we need an equation for the blue side, and we need an equation for the red side. So think y equals mx plus b. We need the slope, and we need the y-intercept of the blue line. Now, looking at where the line crosses the grid lines, I'm going to put some dots down. It seems to be going like this. So from left to right, it's going down to right 1, down to right 1. So that means negative 2 over 1, which is just negative 2. So when I do my y equals mx plus b, this will be negative 2x. Now the b is the y-intercept, and I can see that the line crosses the y-axis right here. So that's why I will have negative 2x plus 2. Now let's switch over and look at the red side. So first of all, the slope. Again, I can put some dots on here to see what's going on. From left to right, it's going up 2 over 1. So that's going to be a positive 2, so I'll have 2x. Now the y-intercept is a little more tricky. Normally I would extend this line by continuing to go down to left 1 until I got to the y-axis. But you can see this goes right off the graph. So here's what I do to find this missing b value. I will go back to the model y equals mx plus b, and so we are looking for this b. Now for y and x, we can simply use the vertex. So here's the vertex right here. This is the point, let's see, 5, comma, negative 8. So this is an x and a y. So if I substitute these values from the vertex into y equals mx plus b, then I will have negative 8 equals. Now for the m, here's my slope right here, so that'll be 2. And then the x is 5 plus b. So I should be able to find b very easily. So negative 8 is equal to 10 plus b, subtracting the 10, and I find that b is equal to negative 18. So that makes this 2x minus 18. All right, so if you can't just see where the line crosses the y-axis easily, then just substitute your vertex into y equals mx plus b, and you can find the b that way. So now we need the domain restrictions. If x is. Now consider the axis of symmetry, which is right here. All right, the line that splits this down the middle. This is the line x equals 5. So the blue part of this function is to the left of the axis of symmetry. So that's why I'm going to say less than 5, because it's to the left. The red piece is to the right of the axis. So I'm going to say if x is greater than 5. Now, right now, both of these would be open circles, so I'd have an open circle right here at the vertex. I don't want that, so I'm going to make one of these or equal to So I'll just make the top one or equal to. For absolute value functions, it doesn't matter which one you make or equal to. It does matter for problems like number 8, when you have an open circle and a closed circle. All right, the or equal to is going to correspond to the closed circle. So that's it for number 7, except for the domain and range. This goes left forever and right forever, so that's negative infinity to positive infinity. It goes down, the range is y values, bottom to top. So at the bottom, we have negative 8. And at the top, it goes up forever. So that's negative 8 to infinity. All right, with a bracket, it touches negative 8. So that's it for number 7. So now let's take a look at number 8. All right, let me change the colors similar to what I did on number 7. All right, so again, we're going to start off with f of x equals, and we'll set up our braces. So I'm going to need an equation for the blue piece and an equation for the red piece. So I'm still thinking of y equals mx plus b. So I need my slope and my y-intercept. So let's see. Let's put some dots on here. It seems to hit the grid like this. So from left to right, it's going up 1, right 2. So that's positive 1/2 x. Now I need the y-intercept. Well, the blue part crosses the y-axis right here at 2. So I will have 1/2 x plus 2. Now let's go ahead and jump over and do the red side. Again, I need the slope and the y-intercept. I'm going to put some extra points on here. All right, from left to right, it's going down 1, right 1. So that's negative 1 over 1, which I will just write as negative x. Now, I need the y-intercept. I can probably guess where it's going to land because it's pretty close. But you know what? Let's practice using our y equals mx plus b skills. So think about y equals mx plus b. Now, there is no vertex because it's not an absolute value function. But that's okay. All I need is a point that's on this line. And an easy point to pick is this one, the end point. So we can just use it. So this is the point 2, 9. So I could just use that. So the 9 is the y value. The slope is negative 1. So I could just put negative 1x. And then up, I didn't mean to put x. All right, our x value is 2 plus b. So I have 9 is equal to negative 2 plus b. Add 2 to both sides, and that is 11. So b is 11, so that means negative x plus 11. All right, and you could probably have guessed that by extending the line. If I just kept going up 1, left 1, it would have hit right here. We could have figured out it was 11, but that's good practice. Now, on a graph like this, there's no axis of symmetry. However, right here is where it changes from the blue part to the red part. So it's not an axis of symmetry, but still the value x equals 2 is where it changes from one part to the other. So that's what we will use for our domain restrictions. So we will say if x is less than or equal to 2. I said less than because this piece is going to the left. That's where the lesser values are. I said or equal to because it's a closed circle. Now on the red part, if x is greater than 2. All right, greater because it's going to the right, and it's not equal to because open circle. That just leaves the domain and range. This goes left forever and right forever without missing any x values. So that's negative infinity to positive infinity. The range is y values from bottom to top. So it goes down forever, so that's negative infinity, up to a height of 9. Now, 9 itself is an open circle, so I'm going to leave this round instead of square like I often do. So that's it for number 8. Now, problem number 9 and 10 refer back to problem number 7 and 8. So let's see. State the y-intercept in problem number 7. All right, there's only one y-intercept in problem number 7 because look at the v. This v only touches the y-axis here. It's the only place. So the y-intercept is at 0, 2. What about the x-intercepts? This v touches the x-axis in 2 places, -1 and 9. So that's why I'm going to put -1, 0 and 9, 0. We already discussed the axis of symmetry, which is the line x equals 5. All right, you must put x equals. Don't just put 5. We've already done the domain and range. All right, of course, the domain is negative infinity to positive infinity, but the range was -8 to infinity. All right, let's see, negative infinity to positive infinity. Now, write an absolute value equation. So we wrote a piecewise function, but if I want an absolute value equation, I have to ask myself, how is this graph shifted compared to the parent function y equals absolute value of x, which sits at the origin? Well, look at this vertex. It's right 5 and down 8. So if I want to go to the right 5, I need to see x minus 5 because left-right motions are always the opposite of what they look like. If I want to go down 8, it's going to be a -8 like this. Now, I might need a number in front depending on the slope of the right-hand side. Remember that this is going up 2 over 1. So that's 2. So that goes right there. So this is the absolute value function. So we have y equals 2 times x minus 5 minus 8. All right, so that's it for number 9. Now, we're going to use the graph from number 8 to evaluate these numbers. So I'm going to evaluate at -6. So look, these are x values. So let's take a look and see what's going on at an x value of -6. All right, I'm just going to clean this up a little bit. Okay, so here's an x value of -6 right here. And the graph is sitting below this right here. So the value of the function is -1 here because it's down 1. All right, so that's why this will be -1. Now, what about an x value of 2? All right, here is an x value of 2. And I see the graph is up above here at 3. So f of 2 is 3. All right, basically they're giving us an x value and they're asking us for a y value. So if the x value is 8, what's the y value that goes with it? Okay, here's an x value of 8. Now if I look up in the sky, here's the y value on the function. That's a y value of 3. All right, so that's it for number 10. So that just leaves these last 4 problems. And this time we're going to evaluate using these equations. So let's see. We have to know which piece to substitute 7 into. Are we going to use the top piece or the bottom piece? Well, that depends on the domain restrictions. If our x value is less than or equal to 3, then we use the top one. If it's greater than 3, then we'll use the bottom part. So let's see, is 7 less than or equal to 3? No. Is 7 greater than 3? Yes. That's why we're going to use the bottom part, x minus 1. So that means we have 7 minus 1, which is 6. Okay. You know what? I just messed up badly. Here's what I did wrong in my haste. You have to pay attention to the letters. This is function j, this is function p. So because this is function p that's being mentioned, I need to do this function over here. So let's redo that. 7. Is 7 between -2 and +2? No. Is 7 between 2 and 5? No. Is 7 between 5 and 9? Yes. So that tells us we're going to use the bottom part. And because these are all just constants, there's no x, then the answer is simply going to be -8. That's all. Now, this problem references function j. So now I'm looking at this function on the left. -5. Is -5 less than or equal to 3? Yes, it is. It is less than 3. So that means I'm going to use the top part. So I'm doing -2/3 times x minus 6. So this is what I'm going to substitute into. So here goes the -5. To fix this, think of this as -5/1. So -2 times -5 is +10. So really I have +10/3 minus 6. It's a little ugly, but we have to deal with it. Now, I could cheat and use my calculator. All right, so I have 10/3 minus 6. 10/3 minus 6. So if you're allowed to use your calculator, you see that it's -8/3. Now, otherwise, you need like denominators. So this is like 6/1. But if I multiply by 3, then this becomes 10/3 minus 6 times 3 is 18, so minus 18/3. Okay, so that's like having 10 minus 18/3. And of course, 10 minus 18 is -8. So that's how I got -8/3. So that's how you do it by hand. All right, the next problem is also about function j. And we have 6. Is 6 less than or equal to 3? No. Is 6 greater than 3? Yes. That's why we're going to use this function now. So x minus 1, and it becomes 6 minus 1, which is 5. Now the last one is great because we're back to function p again. And function p is easy because it just has these constants. All right, there are no variables, so the only possible answers are -1, -6, and -8. So I see the 2. Now 2 is not between any of these. However, 2 is equal to 2 is equal to this and this, obviously. So which one am I going to use, the top piece or the middle piece? Well, the middle piece says 2 is less than or equal to x. All right, so since if x is 2, then that means 2 equals x. So I'm going to use the middle equation. And since there are no variables to plug into, the answer is simply -6. And that's going to be the end of this video. I hope there was something in here that you found useful, and I will see you on the next video.